So again, get out a blank piece of paper because we're going to take notes on what information we know that we can use to help us out with your proofs. And if you happen to have it with you, I would recommend having out your vocabulary sheet. If you happen to have that with you, if not, it's fine. Yeah, the Unit 1 vocab sheet. Okay, so again, if you have your vocabulary sheet, I recommend having that for reference. We'll be referring to that. If you don't remember your properties yet, and you have this worksheet that we did for homework over the properties, you might want to have that out. You might have those practically memorized by now because of worksheet 4, but this is good to have for reference. And if you're still struggling to remember segment addition postulate and angle addition postulate, this reference sheet that I gave you before your Unit 1 test that summarizes your postulates and theorems, you can refer to that. You probably don't need these ones as much because you probably already have that ingrained in your brain. The vocab sheet we will be referring to. All right. So, like we said, we started off with our properties of equality. Did I pull that up? Maybe? Nope. Okay. So, again, you don't have to write this piece down. I'm just going to be saying up here so we can refer back to it. But we have our properties of equality. And we use this with our algebraic proofs, but we'll also be using this with our geometric proofs. Because we've already done in Unit 1 where we had to use algebra and solve equations within geometry. All right, so properties of equality. And this is what we were talking about earlier. And like I said, you can use POE. Actually, I'm going to use a little to shorten it so that you don't have to write as much when you're doing your proofs. All right, so our properties of equality, we have the addition property of equality, the subtraction property of equality, the multiplication property of equality, and our last one, the division property of equality. Alright, so again, anytime we're adding the same thing to both sides, subtracting the same thing from both sides, multiplying or dividing the same thing from both sides, that would be addition, property of equality, subtraction, property of equality, multiplication, property of equality, division, POE. Make sure you have that POE with it. If you just say addition, that's not the correct property. That's not even a property. Alright, so make sure you say addition. Alright, and then some other common properties we used. What are some other ones that we used within worksheet 4 even? What are some other properties? Substitution property, that's a big one. Too fast. So substitution property, distributive property. Symmetric property. And remember, symmetric property, if we have A equals C, then we know that C equals A. It flips it across your equal sign. Be careful not to get that confused with commutative property, which is another one we might use. Commutative property, A plus B is the same thing as B plus A. Alright, so symmetric property, we flip it across the equals. Commutative property, we are moving terms back and forth. And that's only true for addition and multiplication. All right. Were there other properties that we used? Solving worksheet 1. Reflexive, that's another one. We don't use that one as often, but it's still an option. And there's one more that starts with a T that we use. Transitive property. Those are probably our most common ones. Ooh, associative. Yeah, we need that too. Don't forget associative property. Then we also have our multiplicative inverse and our identities. We don't use that as often, but those are options as well. Multiplicative inverse and identity. And additive inverse identity. Okay. So those are what we use to solve our algebraic proofs, and again we'll use that for our geometric ones. But let's take a look now at some of our geometry terms that we'll be using. Now, of course, we have this vocabulary sheet that you may have to say, you know, definition of supplementary angles or definition of array, things like that. But I'm going to pull out kind of the ones that are most common for us. A couple of things that we'll definitely be using. Supplementary angles. So definition of supplementary angles. Definition of supplementary angles. And with that definition of complementary angles. Remember, supplementary, they add to be 180 degrees. Complementary, they add to be 90 degrees. Recall that a postulate is a statement that cannot be proven. It's a statement that we accept to be true because we have to have a starting point. And so we'll use postulates to prove theorems. And later on, as we learn larger theorems that build upon previous theorems, we'll use theorems to prove even bigger theorems. But what are two of our super common postulates that we've been using? Segment addition and angle addition. So we have angle addition and segment addition. Let me try that again. Segment and angle addition postulates. And remember that these are talking about the measure of our segments and angles. You say measure AB plus the measure of BC equals the measure of BC. An angle addition postulate. Angle 1 plus, or the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2. So make sure you remember that these are talking about measure. It's really important for proofs that you remember the difference between measure, equals, and the congruency. So we'll talk about that next.
What is the bottom?
This one?
No.
This?
The other side.
Over here? Multiplicative inverse and identity, additive inverse and identity. Questions so far as what we're doing? Correct. So now let's talk about the nitty-gritty of midpoints, angle bisectors, and what's measures, what's congruence. So I don't think we actually formally wrote down the definition of midpoint, so I'm going to read it to you. It's reading time. Would you like Spanish or English? How about English? I'll attempt to read it in Spanish afterwards. Okay, so midpoint of a segment. Well, first of all, actually, let me ask you, what does it mean if we have a midpoint? It is in the middle of the segment. What does that tell us about the chunks of the series? Right, we have that. It gives us two congruent segments, meaning their lengths are equal. Okay, so the formal definition, midpoint of a segment. A midpoint of a segment is the point that divides the segment into two congruent segments. Notice it says into two congruent segments. It does not talk about the measure of the segments. It tells us two congruent segments. Okay? I will read Spanish in a second. So midpoint, or definition of midpoint, tells us that the two segments are congruent. All right, so assuming we have line A, B, C, where A, B, and B, C are congruent. So definition of midpoint says that segment A, B is congruent to segment BC. Okay, so notice that it says the two segments are congruent. We cannot, by definition of midpoint, say that the two segment lengths are equal. We have to do a second step. Okay, so definition of midpoint tells us that the two segments are congruent. Remember, figures, when we're talking about the picture, the figure itself, those are congruent. All right, here's my attempt in Spanish. El punto medio de un segmento es el punto que divide el segmento en dos segmentos congruentes. That's actually, that's pretty close to the English version.
Thank you for that.
Alright, so definition of midpoint, again, I cannot stress you enough that this tells us that the two segments are congruent. Same with angle bisector. Definition of an angle bisector. This tells us that our two angles are congruent. So I'm just going to say angle 1 and angle 2. Alright, so again, a bisector. Say I had this angle here. Where ray BD bisects my angle, then that means angle 1 and angle 2 are congruent. Again, notice we're talking about congruency here. So then to make the statement that their lengths or their measures are equal, we then have to use definition of congruent segments or definition of congruent angles. Alright, so definition of congruent segments . Knowing that segment AB is congruent to segment BC, by definition of them being congruent, we know then that the measure of AB is equal to the measure of BC. Okay, so be careful that you're not combining these two together. They are two separate things. And then likewise, definition of congruent angles. We know that the measure of angle 1 would equal the measure of angle 2. So make sure you're careful with your notation that you say measure of angle 1 when you're talking about measure, and that when you're talking about measure of a segment, we do not have that line. I think we covered all that. Questions on all this information? This is just a fraction of what you've already learned this year. Isn't that a lot? Yes. Yes. Congruent is with a squiggle on top. When we talk about measures, we talk about lengths that are equal. Is that a question? Okay. So we're going to be pulling all of this information together to help us solve algebraic proofs. We might be given two angles and have to prove that they're equal. We might be given 3 angles and have to prove that angle 1 is converted to angle 2, things like that. So we're going to do a couple examples of that, and then I'll have you work together to work on some problems. Are there people still writing stuff down? Pretty good. Okay. All right, so let's take a look at our first problem. So go ahead and copy this down. It's a quick little drawing where we have segment RT, segment QP, intersecting at point S. And we have that the measure of RS is equal to the measure of SP. And that the measure of QS is equal to the measure of SP. What'd you say? Yes, write this down. So copy this drawing. And so we're given the measure of RS equals the measure of SP, and the measure of QS equals the measure of SP. And they want us to prove then that the measure of RT is equal to the measure of QP. What? So they're asking us to prove that it is true. So I'm not going to give you a proof that you cannot prove. That would be mean. Don't do it yet. We have this copied down? Okay. So whenever I encounter a proof, I like to first just kind of brainstorm through my thinking before I actually write out the formal steps. All right, and you'll see on my keys that every single time, even if the proof is already partially completed for me, off to the side, I wouldn't even look at what had been done. I would brainstorm through it myself and then look at what they did and fill in the gaps. So let's take a look at this. Do you guys think that this statement's true? That this length is going to be equal to that length? Yeah? Why do we think that to be true? I heard the word because and then mumbling after that from various locations.
Yeah.
Go ahead, Chelsea. What? So, careful there. We have vertical angles. Angle RSP and angle QSP are vertical angles. But we're just worried about the lengths of the segments. We don't care anything about the angles. Go ahead. So we know that this chunk and that chunk are the same, and this chunk and that chunk are the same. Well, if this plus that equals the whole thing, and this is the same as that, shouldn't these two be the same? So we can kind of logically see through it, right? So let's brainstorm. Let's think of what we can do. Well, we know we're dealing with segments, right? So if we look at the information we have, we're probably going to do something with segment addition postulate. Maybe, do we have a midpoint? No, so don't even try using midpoint. We cannot assume any midpoint. So we're probably going to be doing something with segment addition postulate, right? And knowing that we have pieces that are the same, we're probably going to have to use substitution in there. Substitution's a pretty common thing to use. All right, so again, right now I'm just brainstorming. If I had the ability to do this off to the side and it'd still be on the board, I would do it off the side. So you might want to do this off to the side for yours. All right, so I know that the measure of RS is equal to the measure of SP. And I know that the measure of QS is equal to the measure of SP. And probably going to use segment addition postulate. We don't have a midpoint. So looking at my segment addition postulate, I would say that RT is equal to the measure of RS plus the measure of ST, right? And I would also say that the measure of QP is equal to the measure of QS plus the measure of ST. Okay, now can I take pieces of these and somehow manipulate these two statements to get them to be equal? Because I'm trying to get that measure of RT and the measure of QP are exactly the same, right? Right now we've got 4 different chunks. But I know that RS and SP are the same. Alright, so I could probably substitute in here RS. And I know that QS and ST are the same. So I could change one of those, right? So I'll change this to QS. Oh look, and then they're practically the same. All I'd have to do is that commutative property, switch around, and then we've got it. So that's the idea that we're thinking. So let's take that and do it formally. We have the idea of where we want to go with this. Let's go ahead and take that and do it formally. I'm going to just move this off to the side down here. I'll stick it up there so we can see what we're thinking. Alright, so this is my thought process. And you do not have to brainstorm. If you want to just dive into the proof. Oops. If you want to just dive into the proof, that's fine. I just don't like writing it out and then realizing I'm wrong. Erase, erase, erase. Try it again. Oh, I did something wrong again. Erase, erase, erase. I like to brainstorm on the side first. Okay. So to set up my table, I have my statements on one side, on the left side. And I have my reasons on the right side. Now, do keep in mind that for the segment addition postulate, I could have also said, instead of just RT, the measure of RT equaling the measure of RS plus ST, I could have said that ST equals the whole length minus RS, right? Not that we necessarily need that for this problem, but just keep that in mind that you can use that angle or that segment addition postulate and move pieces around. Okay, just keep that in mind. That might be helpful for later problems. Okay. All right. So let's start off with my first statement. I'm going to go ahead and start with what's given to me. Right? So RS, the measure of RS equals the measure of SP, and the measure of QS equals the measure of ST. That is given to me. How do I know I can state that? Well, it was given to me, so that's my first reason, given. Okay. Now, sometimes we have a lot of information that's given to us. You don't have to list all of this right at the beginning, because you might not need all of it for your first little bit of your work. So let's say that I didn't need the QS equals ST yet. I could have just stated RS equals SP for my given, and then later stated that when I needed it. Okay, so later on when we have a huge chunk of information given to us, you don't have to list it all out. Pull it in as you need it. Okay, so then we did some stuff with segment addition postulate. So let's set ourselves up for that. And I'm going to stick with using segment, or the measure of RT and the measure of QP, because that's what I want to finally finish with. So moving things around, I don't think is going to help me out. Alright, so I have the measure of RT is equal to the measure of segment RS plus the measure of segment ST. And then I can use that also for my segment QP. So the measure of QP is equal to the measure of QS plus the measure of ST.
Is the lines today mean congruent or the same measure?
These?
Yeah.
Means that they have the same measure. But you can take that and then say that they are congruent if you need to. Yeah. So Jack asked, do these lines mean your same measure or saying that they're congruent? It means same measure, which you can then say that. Okay. So with this, what did I use to make these statements? How do I know I can make those statements? Segment addition postulate. And Michelle, here's an example where I technically did it 2 different times, but since I was doing the same thing, I didn't have to list it as a separate statement. If you do, that's fine. But if you're doing the same, if you're using the same property or same postulate, you can use both in the same statement. Okay, and then we start doing some substituting, right? We want to get my RT equation to be the same as my QP. And you might substitute different values than I do, just as long as they're the same as you. Okay. So the measure of segment RT, I'm going to go ahead and do what I did in my brainstorming, is the measure of segment RS plus, instead of ST, I'm going to use QS. And then I want my QP to be the same. So since I have QS, I'm going to keep my QS. And I'm going to change the measure of SP to be the measure of RS. What property did I just use there? Substitution. Okay. Can we yet say that the measure of RT equals the measure of QP? No, why not? Well, we see the measure of RT is RS plus QS. The measure of QP is QS plus RS. Right, we got to use commutative to make them exactly the same before we can say they're equal. So use commutative property. So step 4. I think I'm just going to change the measure of segment RT. So measure of RT is equal to the measure of QS plus the measure of RS. So just commutative property there. And then I can finally say my final statement. I can now say that the measure of RT is equal to the measure of QP. See, that's exactly what we're wanting there. And what property did we use here? Substitution again. If you said transitive, that would have worked too. Substitution. And again, double check to make sure that your final statement matches what you're trying to prove. They have to be exactly the same. Questions on that? Okay, show me thumbs up, thumbs middle, thumbs down, how you feel about this so far. Okay, so again, what we did with this problem here, we took a look at what information they gave us, then we brainstormed about what we could do with that information and what we know with our theorems, with our postulates, and with our definitions. We then compiled that together to present a logical argument that shows that the measure of RT is indeed equal to the measure of QP. Make sure that you're giving the proper reasons for each step that you do. Do not combine 2 steps into one. Do not do substitution property and commutative property all in one. I want you to do 2 separate things. But again, like we did with step 2, we had segment addition postulate twice. That's fine to leave it in this. Okay. So I actually pulled this from my high school geometry textbook. This guy right here. Why? Yep, this is it. So funny. See that? There aren't very many pictures. There's none of this avatar-looking stuff. Okay, so this is my high school geometry textbook. Isn't it great? Partway through, the page numbers kind of start to get cut off. But so anyways, so the textbook actually does this a different way, and so I'm going to show you that way as well, just because sometimes your brain might think through it a different way than mine does. And you may go about it a different way than the person next to you does. I was really good in geometry at taking the long way. So my recommendation is to try to find the shorter way because it goes faster. But if it takes you 8 steps to get there and you do logically get to the conclusion, that's fine. You don't have to have the exact same answer that I do as long as your logical argument is valid. Okay, so let's take a look at how the book is. Okay, so I've gone ahead and copied it over. If you want to do it below it, or if you just want to watch, that's fine. Okay, so again, we start off So we have our statements. And we have our reasons. And again, the first statement that it did was given. We have the measure of RS equals the measure of SP, and the measure of QS equals the measure of ST. That's our given. Now, whereas we took the segment addition postulate and then whittled that down to make it so that these two segments were equal, they actually started with what was given and built it up to show that these two segments were equal. Okay? So what they did then was that they went ahead and just took their first statement and they added the same thing to both sides. Okay? So we have then the measure of RS plus the measure of ST is equal to the measure of SP plus the measure of ST. Okay, so notice they just took my original statement and added the same thing to both sides. Okay, so that would be my additive property of equality. Okay, so right now we have just built up the angle addition pieces for RT, right? But we don't quite yet have QP. We have SP plus ST, but we need plus SQ. What can we do? Can I get rid of it? Substitute, right? So I have this is good. RS plus ST. I can make that it's going to be RT, but we don't want to do it quite yet. But we want QP. And right now I have the measure of SP plus ST. But I want SP plus SQ. Well, how conveniently we're told that SQ and ST have the same measures. Alright, so you can do substitution and say RS plus the measure of ST is equal to the measure of SP plus QS, because we know that QS equals ST. So that's substitution. And then by the angle or the segment addition postulate, I know that RS plus ST is equal to the measure of the whole line, RT. So I know that this, by the segment addition postulate, is just simply the measure of the whole line, RT. And this is simply the measure of QP. And that's by our segment addition postulate. Okay. And then we look, and they are indeed exactly the same. So notice there was two different ways of going about it. You still use the same ideas. We still use substitution in our segment addition postulate. But like I said, I started off by stating my segment addition postulates and then working down to get to this. Whereas they started with their given and built it up to get to your segment addition postulates. So either way works. Again, as long as your statements are valid and your reasons match it, then it's fine. You may go about it different ways. Questions on that? Okay. So let's take a look at this next problem with angles. So go ahead and copy down this problem. I'll zoom it in for you. So we have angle AED, angle AEB, BEC, and CED. And to make things a little bit nicer, they went ahead and labeled it with angle 1, angle 3, angle 2. Angle 1 and angle 3 being the same measure. they give us this diagram here, and they tell us that the measure of angle 1 is equal to the measure of angle 3. And they want us to prove that angle AEC is the measure of that is equal to the measure of DEE. They want us to show that this measure is equal to this measure. Okay. So again, let's brainstorm. Okay, so do we have any type of angle bisector here? No. So we're not going to use that. Again, take a look what we've got. Do we have supplementary angles or complementary angles? Was there any right angle symbol on that? No, so we can't assume that it is. So we really, what can we even use from here then? Angle addition postulate, probably definition of congruent angles if needed. So we're probably going to be using that again. And then with our algebraic properties. So let's think through it. So I know that AEC, again, this is just my brainstorming here, is equal to angle 1, measure of angle 1, plus the measure of angle 2. Alright, and I can do the same thing with BED. The measure of angle BED is equal to the measure of angle 2 plus the measure of angle 3. And they told me that the measure of angle 1 is equal to the measure of angle 3. And they want us to show that these two are equal. Do you have an idea of what we could do with this? Yeah, it's going to be basically the same idea we did last time, where we can just substitute in 3 for 1, and then it's exactly the same. Okay? So we'll go through this a little bit quicker, since we already kind of have the idea of what we want to do here. And again, I'll move this kind of up and out of the way. Okay. Alright, so I have my statements and I have my reasons. Again, I'm going to go ahead and use my given because I'm going to be using that right away, so I'm going to go ahead and state that. Measure of angle 1 is equal to the measure of angle 3, and that was given to me. Woohoo! Alright, angle addition postulate, that's really the only thing we can do with the limited information that I have. And I'm going to need both pieces, so I'm going to go ahead and state both pieces. And again, depending on your diagram, maybe you wanted to say instead, measure of angle AEC minus the measure of angle 2 equals measure of angle 1. You could do that, and you could substitute that into the other one, and then you'd find that they simplify down. Again, there's different ways of going about it. So measure of angle AEC is equal to the measure of angle 1 plus the measure of angle 2. Likewise, by angle addition postulate, the measure of angle BED is equal to the measure of angle 2 plus the measure of angle 3. And that is my angle addition postulate. Alright? And I use that for both pieces. Yeah.
Slow down. Yeah.
Sure. Go ahead. I'll pause.
Sorry.
So again, all we've done is simply taken a look at the information they've given us, looked at the diagram, and kind of brainstormed through our thought process. We know 2 of the angles of the 3 to be congruent, and so we want to show that 1 and 2 paired up together is going to be congruent to 2 and 3. The measures will be the same. So all we've done is stated what was given to us, and then we used angle addition postulate so that we can incorporate the information that we know. Measure of angle 1, measure of angle 3. Then we're going to manipulate this so we can get them to be exactly the same so we can draw our conclusion. Yeah.
So you move things around to get the beat.
We do what?
You move like
So I stated these statements using angle addition postulate. Then I'm going to substitute in measure of angle 1 for 3, or you could do measure of angle 3 for 1. You'll have that they're the same, and then I can substitute this in for the statement because they are the same. Just like we just did with the segment addition postulate, where we had, once our two statements were the same, then we could say that they were equal to each other. Okay? So again, I'm trying to show that AEC and DEB are the same there. I want these to be exactly the same. They're not quite there yet. We need to make them exactly the same. Right. Now I know that angle 1 and angle 3 are congruent. The measures are the same. So I'm going to substitute that in to make my statements the same. So the measure of angle AEC, I'm going to go and substitute in measure of angle 3 for the measure of angle 1. So measure of angle 3, instead of measure of angle 1, because I know that they're equal, plus the measure of angle 2. And I substitute them. So it's substitution. Questions on what we've done so far? Okay. Now, does AEC, this piece, look exactly the same as BED? No. They're close though, right? What do I need to do? Commutative property again. Because I need this to look exactly the same. The measure of angle AEC is equal to the measure of angle 2 plus the measure of angle 3. Now, if you would have thought far enough ahead, you could have actually set it up from here, measure of angle BED. You could have said is the measure of angle 3 plus the measure of angle 2. So you could have anticipated that and saved yourself a step. But if you don't, that's fine. Just do that extra step there. And so that's my commutative property. Yeah. Symmetric property, that's a good question. Can this be symmetric property? Symmetric property swaps them across the equal side. So symmetric property would be saying measure of angle 2 plus measure of angle 3 is equal to the measure of angle AEC. So it moves it across the equal sign. This just moves the order of the terms. That's a good question. Sir Rob, what's your question? If you did not change it before saying them equal to each other, then yeah, you would lose points for skipping that step. You have to be very thorough with your proofs. Okay, so then now this piece is exactly the same as this piece here. So then I have, and let's take a look at what we want to say. Measure of angle AEC. So measure of angle AEC is equal to this, but we know that that is just equal to the measure of BED. Measure of angle BED. Now, I am okay with you. Notice how when I labeled my angle, I said BED rather than DEB. I'm fine with you at whatever point you want to within the proof. If you did that, I'm perfectly fine with you going ahead and switching that without having to state anything. That's just a matter of the order in which you listed the angle there. Alright, so then this is my substitution property. Make sure that you have exactly the same as what we had above. If I have exactly the same statement, then I have properly proved it. Exactly the same, so I know that I proved it. No. Questions on this?
Oh, this is on algebraic proofs, right?
Algebraic and geometric proofs. So what we did last class, what we did today. And all we did today was basically just incorporate midpoint, segment addition. So it's really the same idea, just incorporating those couple of variables. Again, keep in mind that you won't see me until Tuesday, so come see me if you have questions before you speak. Alright, I'm going to pass out your homework to you. I want to take a look at the first problem. Okay, so real quick, I want to take a look at the very first problem, because the first step was not difficult, but some people were getting themselves tripped up on it. So the very first problem, they give us that the measure of AD is equal to the measure of 2 times the measure of AB plus BC. So that was our first step given. Now the second step, everyone wanted to do something with substitution. They're like, did they substitute something in? Did they add something, subtract something? We'll take a look. The whole segment AD is made up of the measure of AB plus the measure of BC plus the measure of CD. So that's all that this is here, is just your segment addition quotient. Okay, so there's no crazy substitution, multiplying, dividing going on here. It's just simply the segment addition quotient. Okay? So I don't want you to get caught up on that because you were trying too hard. So remember, you have a quiz next class over this material and algebraic proofs. This packet is due next class. Make sure you come see me if you have questions before. Also, there are quite a few of you that when you were absent, you didn't show me homeworks from those days you were absent. Make sure you get those into me ASAP.
I'm so happy. And then we go, oh, my English teacher screwed up. And then she said, yeah, I know.